Hello, I am Professor Deepak Bhoge. Welcome you in my eConcept channel. In this video, I will talk about how to improve the efficiency of an engine. And in the last lecture, we have seen efficiency of an engine is a function of its high temperature and low temperature. So from this equation, it is clear that efficiency is a function of its high temperature and low temperature. Now for increasing the efficiency of this engine, we have three options. Efficiency of Carnot engine can be increased by decreasing the lower temperature, that is a T2, or by increasing the higher temperature, that is a T1, or we can do both simultaneously by decreasing T2 and increasing T1. This case will give higher increase in efficiency as compared to individual case. Now how the efficiency of Carnot engine increases by decreasing lower temperature. In this formula, if you see, as a T2 is decreased, then the ratio T2 by T1 is reduced and 1 minus T2 by T1 will be increased. Another case, if you increase the T1, at that time also T2 by T1, this ratio will be reduced and 1 minus T2 by T1, this part will be increased. So we can decrease the T2 and increase the T1 for increasing the efficiency of a Carnot engine. So and if you do both simultaneously, will give the more improvement in efficiency as compared to individual case. Now in this diagram, if you increase the temperature difference, that is a T1 minus T2, or the length between 1 and 2, if it increases in terms of temperature, then the efficiency of a Carnot cycle increases. So thumb rule is, if you increase the temperature difference between T1 and T2, the Carnot efficiency increases. Now there will be one question in our mind, as we have seen, as we decrease the T2, efficiency increases, as we increase the T1, efficiency increases. But one question will come to our mind, if you reduce the T2 by 10 degrees Celsius and increase the T1 by 10 degrees Celsius, which case will give you great improvement in efficiency? So this is the questions, and in many exams these questions will be asked, and we already asked, which temperature increase or decrease of a Carnot engine have great improvement in efficiency of engine. So four options are given: by increasing lower temperature, by decreasing lower temperature, by increasing higher temperature, and by decreasing higher temperature. So for that purpose here we can prove it, or we can solve these questions by two ways. One, we can do it by analytical method, and another by mathematical method. So now in this method I have taken different temperatures and tabulated in a table to see the change in the efficiency with the decreasing and increasing the temperature. Now case 1, in which we have kept T1 constant and T2 is reduced. So we have kept T1 constant as a 500 Kelvin and T2 is reduced from 300 Kelvin to 260 Kelvin by 10 degrees Celsius. The temperature difference between T1 minus T2 is 200, 210, 220, 230 and 240, and then efficiency is increased from 40% to 48%. This is the case 1, in which T1 is a constant and lower temperature is reduced. Case 2, in which we have kept T2 constant, that is a 300 Kelvin, and T1 is increased from 500 Kelvin to 540 Kelvin. So in case 2 also there is an improvement in efficiency from 40% to 44%. And in second case, the temperature difference is similar to the case 1, that is 200, 210, 220, 230 and 240. And if you compare in both the cases change in efficiency or increase in efficiency, case 1, in which there is a more improvement efficiency for the same temperature difference than the case 2. So in case 1 we have reduced the lower temperature for improvement in efficiency. So from this table we conclude that by lowering the lower temperature we will have great improvement in efficiency, as compared to increasing the higher temperature. So same graph is plotted with the help of this table. Graph is plotted here. In this graph you can see the case 1 blue color line is in which T2 is reduced and T1 is kept constant, so its slope is higher than the case 2. In case 2 T2 is a constant and T1 is increased, so its slope is less. Okay, so case 1 has more slope, and if some system has more slope or curve has more slope, then it has a more change. So another way to find out the answer of these questions, we can differentiate these efficiency equations to check the slope of the curve. So how to prove it mathematically? Now for prove it mathematically, we have taken the equation of efficiency 1 minus T2 upon T1, and if you differentiate these efficiency equations with respect to T2 by keeping T1 constant, and another case, differentiate equation with respect to T1 by keeping T2 constant. Now in the first case, we have kept T1 constant and differentiated with respect to T2. Then we are getting 1 is d efficiency by D2 is equal to minus 1 upon T1. Now multiply these equations for the simplification. Multiply these equations by T1 and divide it by T1. So we are getting finally equation 1 as a T1 upon T1 square. This is equation 1 in which efficiency is differentiated with respect to T2. Now in case 2, differentiate efficiency equation with respect to T1 by keeping T2 constant. So we are getting T2 upon T1 square. So second equation is a T2 upon T1 square, and equation 1 is a minus T1 upon T1 square. If you compare the slope or the values of the equation 1 and 2 right hand side, the denominator of both the equation is a T1 square. Now the equation which has numerator higher value has a higher slope. If you compare equation 1 and 2, equation 1 in which numerator is a T1 and equation 2 in which numerator is a T2, but T1 is greater than T2, so equation 1 right hand side value will be more than the equation 2. So as it is a slope, d efficiency by dt is the slope of efficiency versus temperature. So slope of equation 1 is greater than equation 2. Therefore, from this diagram it is clear that blue color line has a great slope or more slope than the brown color line. So blue color line is the line in which T2 is reduced. So this is how we can prove mathematically the change in efficiency with respect to T1 and T2. And from this slide we can conclude that the decrease in lower temperature of a Carnot cycle or Carnot engine has great improvement in efficiency than the increase in higher temperature. Thank you. These are the references used for preparing this video.